Hello, everyone. This is Elisa Baum, Percona's Director of Product Marketing. We'll begin in just a moment, but first I'd like to conduct a bit of house cleaning. Could you please raise your hand using the hand icon located in the GoToWebinar control panel to let me know if you can hear me? And let me see. Can you guys hear me? Oh, okay, great. I see some hands. Perfect. Next, during this webinar, you will be on mute. Should you have any questions at all during the discussion, go ahead and enter them in the questions field within the control panel. At the end of the webinar, we'll take time to answer as many questions as possible, and those that aren't addressed will be answered in a follow-up blog post on Percona's MySQL Performance blog. In addition, a recording of this webinar will be made available to everybody within 48 hours. With that said, I'd like to thank you for attending today's webinar, OpenStack, a MySQL DBA Perspective. It is being presented by Principal Architect Yves Trudeau, and in addition, our Director of Product Management, Tushar Katarki, will be joining us for the questions and answers part of the show. With that said, I'd like to turn the floor over to Yves. Go ahead, Yves.
So, welcome to this webinar. Today I will be talking about OpenStack for MySQL DBA. So it's a perspective on the OpenStack project for DBAs. My agenda is I split the webinar in two parts. So the first part covers what MySQL can do for the OpenStack project as a backend data store. We'll do some planning, estimate, and look at high availability options for MySQL. And in the second part, we'll reverse the point of view, if you want. We'll look at running MySQL inside OpenStack. So we'll look at what are the options. We'll discuss some performance issues and look at HA solutions. So let's first start. MySQL for OpenStack. So as you see, all the main components of MySQL, I think Centimeter is one of the only one that doesn't use MySQL, are all connected to MySQL in some way. They have their own database in it, and they store data. So let's see. So first, we'll look at some planning. What's the query load on MySQL database inside an OpenStack cluster? So if you are fully asset, so inside OpenStack, inside MySQL, you will have InnoDB flush log at TRX commit equal 1. Commit will likely be your most heaviest query in terms of load, because the way the ORM work, it issues a lot of commits, even though those are empty. So commits are never cheap. It needs a flush and an fsync, even if they are empty. So it's a bit heavy there. If you're not fully asset, it will still be probably the query, but not by an as large margin. The data set size is rather small. I mean, the only thing that could be a problem is the keystone tokens if they are stored within the database. If you do that, so I believe the most efficient way is to store them in memcached, but if you do store them in the database, then I suggest that you cron the keystone manage token flush command. I mean, it can be as frequent as once per minute. I've done that, and it's I think better to flush more often a smaller number of expired tokens than to flush thousands of tokens at the same time. Another thing, all the services and agents have tables where they put their status. So for large cluster, you'll see a lot of updates on these tables. Usually the period is like 10 seconds. But if you have, let's say, 1,000 nodes, compute nodes, still 100 updates per second on those tables. That's something we'll need to take into account later when we will discuss HA and other solutions. So in terms of query load, if I continue here, if you look a very simple query, a bit like the dev stack or a very small one with less than 10 compute nodes, you will see between something like 7 to 15, 20 queries per second on average. So it's rather tiny. It's not a lot. It's not a big deal. Performance-wise, it's rather small. It's probably, if you go to a very large cluster, it would be something else. Some are static in size. They don't scale the number of nodes. Others do scale. I talked about the updates of the services and agents. And agents, that's one that will scale with the number of nodes. If you look at the queries, there's many subqueries. Those subqueries are usually better handled by 5.6. The 5.6 optimizer is much more efficient at dealing with subqueries. 5.5 and earlier will treat many subqueries as dependent, although they are not, and they will be executed for all the rows, which can be a problem. Although if it's a small cluster, you don't really care because of the query load. But if you are running a large cluster, I would think 5.6 is much better adapted. I also found some poorly written queries that do cutters and join when they shouldn't. So it's really part of the way the queries are coded. I don't think it's SQL actually doing anything wrong. It's just there's an extra setting in the query that is wrong. I'm planning to submit a patch as soon as I have time to prove that I'm right in there. So that will be, I hope, fixed very soon by a Percona contribution. And also there's some missing keys, which you don't really care when you have, when your database is young and a small cluster that has not much in it. But as it grows, you have to know that OpenStack doesn't delete any row except for the token when you do a flush. It marks the row as deleted. There's a column for that. And as it grows, it can become problematic. So database size now, it's tiny. I mean, really tiny. A setup with, I have a setup in our OpenStack lab. It has 6 data nodes, and I think the whole data set fits in less than a few meg. So it's really small, which is good. Although, like I said, if you don't do the cleanup, you'll have a lot of deadwood in your database, but that's normal. I already talked about the way OpenStack deletes very few rows, so we'll need to do some cleanup. I've not seen anything other than the token that does the cleanup, but it's usually fairly easy. All the rows have created time, and there's a deleted column. So for things like instance, volume reservation, IP reservations, and all that, eventually we'll need to do some cleanup there. Finally, I don't know which kind of cluster could give you more than 1 gigabyte of data. Probably if you're HP or rack space and you have thousands of compute nodes and a very complex cluster, you could end up with a data set that is large, considering that you do the cleanup and all that. But 1 gigabyte of real data for OpenStack is large. I mean, that would be a good cluster. So another thing we need to start thinking, if you are using multiple data centers, you will need to do some planning ahead of time. Really, the only databases that need to be copied from one data center to the other one, in my sense, maybe I'm missing something, are Keystone and Glance. Keystone for the users, that's quite obvious. If you have a user connecting to the remote data center, have to use the same credentials. And glance, that's for the images. If the images are, of course, if you replicate glance, you need to replicate the images that glance refer to in some way that the remote data center has the same images available. So now that we've done some planning, I'll just review the HA solutions that are available for the MySQL service as part of OpenStack. First, XRDB cluster with or any Galera-based solution like MariaDB is currently, I think, the preferred solution if you want HA for MySQL. It works well. It's very simple. All nodes are available. You do need something to connect to a valid node. HA proxy is a valid way. There's a few other solutions using Pacemaker that could do about the same thing, but that will give you a connection to a node that is in sync and part of the in the same state to answer your query, serve. Ideally, it's always better with the XRDB cluster to use one node for writes. It avoids things like fake deadlocks if the certification doesn't work on another node. And since the query load is small, there's no real reason not to do that. So it's probably safer and simpler to send all the operations to one node. If you use Galera, you need 3 nodes. For any quorum that makes sense, we need 3 nodes. But one can be an arbitrator, the guard daemon, which does act as a member of the cluster for the protocol, but doesn't deal with the data, just receives the traffic. Another solution that will work well, I've not tried it, but I look at queries and it seems quite obvious, NDB cluster. I know, that's not the simplest. It's probably overkill in terms of query performance, but the fit is quite good. There's many small queries. The data set is small, so it could be used without any problem there. One of the good points, all the SQL nodes are active. You still need HA proxy if you have a lot of nodes, if you have many compute nodes. But here, if you don't have too many, every compute nodes and every node that needs to talk with MySQL could have a local SQL node that connects to NDB data nodes, and so you don't need any load balancing. When you connect to for MySQL, you connect on localhost, and that's it. It's that simple. Next, another solution that works. Whoa, skip one. Wait a minute. Oh, come on, this one doesn't show. Okay, another one that would work perfectly well is Pacemaker DRBD. It's the old solution of a shared disk that works, I think, my first setup like that in 2000, so it's many years ago. I believe, I'm not an expert in PostgreSQL, but I believe the only solution with PostgreSQL that gives HA, and that's what Suzy is using in their cloud manager for OpenStack. Like I said, it's a well-known solution. I mean, it's there since the beginning of the world. It works well. Failover is rather consistent. It's the behavior is same. The only thing after failover, of course, once you the standby server has mounted the DRBD device, database needs to do recovery, and then when it starts, the cache is cold, so the performance may be degraded a bit. I don't think it's a big issue here because the query load is not high, but it could. And another thing, like for guard, it's a cluster. It needs quorum. So usually the best thing is to have 3 nodes. One can be a standby node. If you use a SAN instead of DRBD, DRBD is a SAN emulator, you can use the SAN as an arbitration device. But if you use just DRBD, you need a third node to serve as arbitrator. Next, another solution still using Pacemaker is the Percona Replication Manager, PRM. So this use replication. So if you have a failover just after a big update, some of the information may have not been transferred to the slaves. So if you promote a slave to be a master, it may be missing. So you have to just consider this. The worst that could happen is like you started a VM, it has not been recorded as started, and it started, but OpenStack thinks it's still down. But there are some cleanup procedures for that, and it should be very, very exceptional. Next, of course, within the OpenStack cluster, in such a case, there's a virtual IP associated with the master, and all the OpenStack services will talk to MySQL using the virtual IP. So that's pretty simple. A good point here, after failover, MySQL is warned. So the slave was already a slave, was already running queries, all the rights queries. So it may not be in the exact same warm state as the master because it's not running the selects, but it's not cold at all. So it should usually those kind of things pick up very quickly. And again, it's Pacemaker, you need 3 nodes. So same as for the RBD setup. So we've talked about local HA. What about if we discuss geographical disaster recovery? So you have multiple data centers and you want to failover between them. Of course, here when we talk about database failover, like I mentioned earlier, we're talking about Keystone and maybe Glance. So if the OpenStack cluster is very large, and you want just to replicate those 2 databases, you'll need to have 2 PXT set up. If you only have one, everything will be replicated. So that's another point. And if you have a large cluster, you'll have a lot of comments. And as a DB cluster, you will pay the price for every comment, you pay the latency price. So if you have one thread applying the updates, you will be limited to the number of round trips you can do. So you will need many appliers to give some decent transaction capacity. And it's still heavy over the WAN. Even though you have a big pipe, you cannot beat the speed of light. So there's always a problem there. A good solution, in my sense, would be to mix XRDB cluster or Galera with working as an HA service locally and connected through replication, like with PRM, over the WAN. So you have synchronous replication locally, asynchronous for disaster recovery. I think that would be a very good option. I'm discussing with a few guys here at Percona to implement a Pacemaker solution that can do that in the same way. I think it's rather easy to do. There's a few hiccups that we need to be careful, but so basically you run Pacemaker on both sides and it picks a master and a slave and adjusts replication so that it works. So that would be the point of it. So now we're covered. I'm almost done with MySQL for OpenStack. Let's see what we have viewed, what we have seen so far. So the dataset size and the load are moderate, to say the least. I would even say tiny. In my lab, the database could run on a Raspberry Pi without any problem. Galera is kind of preferred solution for high availability. I put the word scaling here, but we don't really need scaling. So for higher availability with the OpenStack database service, And for multi-site, I think asynchronous replication makes the most sense. You don't really care about something that is transient, because if the main data center is down, you don't mind if it's not already applied on the other side. You don't mind if you lose a few transactions. So I think that's the best fit for the GeoDR solution. So now that we reviewed MySQL running as a database service for the OpenStack cluster, let's reverse the case. So here, from now, we'll talk about running MySQL inside an OpenStack VM. So typically, you have the VM handled by Nova. The database runs on a block device created by Sender. So I'll review all the possible options for MySQL deployment. Of course, standalone replication, if you doubt, it obviously works. It's very simple. It's same as AWS and other solutions, so it works. I suggest you use a fixed IP, so you create a neutron port with assigning an IP to a port, and then when you launch a database instance, you assign the port to it so that it has an IP that is fixed. It's implemented as the HTTP reservation, so it's, that will guarantee that there's no IP switch from the server. Another solution that does work as well is Galera, so XRDB cluster or MariaDB. There's nothing specific here. Again, to ease the pain with the configuration, again, I suggest the same trick would be fixed IPs. There's one thing that you can do with bare metal that you cannot do here is multicast. Although maybe I missed something, but I don't think multicast works from what I've seen. So if you were planning to use multicast to save bandwidth, that's probably not a very good solution. It won't work. You have to do a regular point-to-point communication. So that would be easier. And you need a way to load balance to a valid node. The best solution, again, I think it's HAProxy. HAProxy will have all the cluster members in its configuration, will query the nodes. The trick is to use an xinetd service that is a front end to cluster check, a script that will return yes or no, basically, if the node is valid, and HAProxy will direct traffic accordingly. There are ways, if you have a lot of nodes and a big cluster, to have a daemon instead of could be another way to, if you really need to scale far. On Galera, there's one good thing that OpenStack allows. So if the Cinder backend supports snapshots, I have in mind here Ceph. I played with Ceph and find it really cool. So we could do, and that's something, it's an idea that is finding some love inside Percona right now, that you could define an SSD script. So when a new node join an XRDB cluster, or if the node was down or bad data or something, it needs to get a copy of the data set. And that is expensive. The most efficient way right now is to use extra backup, but even then it puts a load on the cluster. So a good way would be to use snapshots. And if you're on Ceph and your database are all mounted, the data set, I mean, on a specific Ceph volume controlled by Cinder, you could ask for a snapshot. So basically you freeze your write, save your transaction position and all that, the same way as XRDB cluster does. start the snapshot, release the write, and mount the snapshot directly on the receiver. So instead of taking, let's say you have 500 gig, instead of taking, let's say, half an hour copy, depending, it could be done, since it's a snapshot done on a copy on write system with the clone on the snapshot, it could probably be accomplished within a few seconds. So I think it's something very cool that OpenStack allows, because they all share the same storage pool. So that would be very, very great. Another solution that works, I've done a lot of NDB work, so I kind of like it for when it's good. When it's bad, it's terrible. But when it's good, it can be very interesting. So it also works very well. I'm repeating myself, but fixed IPs here are very good. It simplifies a lot. The good point is if you don't have too many application nodes, by too many I'm talking less than, let's say, 250, you can easily co-host a SQL node with each application node. So you have the application, the MySQL runs on the same node. The application connects to 127.0.0.1, talk to the local MySQL that knows where the data nodes are and connects and get the data. So that saves the load balancer part of the situation. Again, if you plan to deploy NDB cluster, think carefully. It's fantastic in some cases, disastrous in other cases. If you're unsure, contact us. Finally, one of the rising star is Trove. It's very interesting. It's like RDS, basically, your own RDS setup. It's new, so that means it's not yet mature. If you plan to install it, you may have a rough ride. It's not necessarily easy. Our lab is using Cupid and doesn't seem to like stock with Cupid. So it seems to be some default somewhere that points to RabbitMQ, trying to figure out where exactly. But I'm getting always RPC errors on the backend the connection. If you have a RabbitMQ, it's much easier. So for now, it only supports, I don't know if it's you or somebody typing. Maybe you should mute yourself. Setup. Okay, so if you're planning for something else than replication right now, it doesn't work. It's not implemented, but Percona is working on support for Galera. I have no clue when that would be available, but it's coming. So eventually we could have Trove service that deploys and opens a Galera cluster. So that would be pretty awesome there. So I reviewed all the options. Let's now move to the performance aspect. I think CPU-wise, memory-wise, it's about the same as what you have. The main on bare metal or any other cluster. What may change here is the type of backend that you have. So Cinder supports many backend for block devices. The default is LVM over iSCSI. You can fairly easily also set up a SAN over iSCSI. With such things, you get what you have. If your LVM is on top of a big RAID 10 array with SSDs and or RAID 15K RPM drives, you may get a decent amount of IOPS available. Same with a SAN. But if you're using a single SATA drive, you have some limitation. Another option is to use NFS for the storage backend. I'm not a big fan of running MySQL on an NFS cluster file system. I've seen many problems. So it works. If you have you're very knowledgeable about NFS, you may have something stable, but I've seen a lot of bad story there. ClusterFS is another solution, but up to now it's only available as a user space fuse driver, which limits performance. You can also use an NFS backend, but again, we're hitting the same problems as before. Or, and right now, Gluster doesn't support snapshots, although I heard that it may be coming very soon. I think it's in beta or something like that. But snapshots are not supported. All the other ones, LVM support snapshot, but it's quite heavy. Sans do support snapshot, but it's a bit outside. I don't know if Cinder can fully use them. And of course, I have already talked about it, Ceph. I really like Ceph. I said that before. It's a bit complex, and the integration with OpenStack is not as easy as it could be. But the concept is very interesting, the way it works. And snapshots are super fast. I mean, if you have an OpenStack cluster, you probably know that if you are using LVM over iSCSI or something like that and you start an instance, it needs to copy from glance to the partition that you created. It needs to copy all the image there. So if you have a 30 gig or something image, it can take time. If you're using Ceph for Glance and Cinder, it will just do a clone of the image and start. So instead of taking like 30 seconds to start, you'll be up and running in like 2 seconds. You start, you look, KVM is starting. It's very, very good there. Now, about HA, if you want to run MySQL in an HA fashion within an OpenStack cluster, what can you do? What are the considerations that you have to take into account? First, there's no bit, at least not easily. I mean, it should be possible. There are some anti-spoofing rules that are there that blocks an IP with a MAC address. That's done on the compute node by the Neutron Open vSwitch agent. I guess for a given tenant, it could restrict to a subnet or something, not a specific IP. That would allow this, but right now it's not possible. So, or I'm rather new to the OpenStack world. Maybe I just missed the configuration options somewhere. There's quite a few. So, but I've tried for quite a while and didn't find any way to do it. You can use floating IPs to identify the MySQL node, but that would mean to hop over the network node, to be denatted there to the floating IP where it points. It's not exactly great. I don't really like that. So could be a better way to do that. I mean, in terms of network hop, it's not fantastic. So and it gives visibility to the external world, to the MySQL service. So I'm not a big fan of that either. HAProxy works well. You have to define all your MySQL nodes and some rules, logic to apply to detect if they are in the same state or not, but that does work correctly. I've used many times in AWS that will work just fine with OpenStack. Pacemaker and cursing using the UDP unicast communication mode, so you specify all the nodes. And Pacemaker runs on all the database nodes and all the application server nodes. And on the application servers, what it does, it sets DNAT rules that points to the valid master, let's say. So you connect to a fake address, is intercepted by the IP table DNet rule and rerouted to the correct master. That's fairly easy to set up, and it works well. It avoids any single point of failure with HA proxy, so you don't have to set up or pair HA proxy servers with Keep Alive or something. Even with Keep Alive, since you don't have dips, it's not always trivial. So that's a solution that will work easily. Also, other considerations. I already mentioned that if Cinder supports snapshots, it's possible to do to have a custom SST script for XODB cluster. That would be nice. I really hope that we will provide one anywhere soon. So that would be a very good plus to have. And something that I overlooked in our lab, I will probably need to change a few things there. Think about availability zones. I mentioned that many solutions need 3 nodes for HA, but if the 2 of the 3 nodes end up on the same compute node and that compute node goes down, you're still without HA, so you thought you were in an HA, but you're not. The way to avoid that is to have multiple availability zones. So you create servers in different zones, and you know that a given server is not in only one zone. So you cannot create all your VMs on the same server if you use different zones. So I think that could be a good solution here. So I reviewed, I did an overview of the MySQL aspect of running inside an OpenStack cluster. So in summary, what we've seen, that most of the well-known solutions work correctly. Trove is promising, a bit young yet, but promising. As more options are offered, will probably become a very good way of using MySQL inside OpenStack. The backend choice is very important. Something I didn't mention, in our Ceph cluster that has 6 nodes with a pool of SATA drives and a pool of SSD drives. Using the SSD drives, and I mean, I tuned it very basically. I got with, I think, 32 or 64 threads and Sysbench, I got above 1,000 IOPS. Not a big deal, but it's not bad either. And considering that I did very little tuning and that we don't have a 10 gig network, just a single gigabit network for all communication, it's not bad. So I think it's Ceph is still quite good. The backend, if you want to use a SAN, that's one way of doing things. Or if you are using LV. Sorry. And finally, fixed IPs with neutron ports ease the pain. So it's much easier than to deal with IPs that can change, or so I think it's a much better way to deal with virtual machines. You can predict what your configuration will be based on the fixed IP that you have configured. So that completes my talk. I know it's rather short, it's 40 minutes, but we have time for questions. So questions, that's where it's your turn to ask.
Hello, can you hear me? Hello, can you hear me?
For my part, I can.
Okay, good. Thanks, Yves, for your talk, and there have been a number of questions, but let me say that the first question is actually, does Percona MySQL XDB cluster support multi-master replication?
If XDB cluster supports multiple, supports master-master replication?
Yeah, multi-masters.
You're talking about another XRDB cluster, or because within a cluster, it's kind of master between all the nodes at the same time.
Right, and
so
I think that's
right to any.
right.
If
I think that's the question.
So if you are talking about having more, so if within a given cluster, yes, it's the equivalent of multiple master. You can write to any nodes, you can read from any nodes. It's about as simple as that. If you're talking about joining with a remote XRDB cluster, let's say using asynchronous replication, yes, it's possible also. It's a bit tricky, but it's possible.
But I think this was just a basic question as to whether Percona MySQL, the XRDB cluster supports multi-master replication, and the answer is yes, right? I mean,
yes, it is a kind of multiple master within it.
Right. That's right. So there's a follow-up question here, which I think is interesting, and that is, in the case of a Galera cluster or PXC or a Percona XRDB cluster, which is based on Galera, what is the best way to back up the MySQL instance? I think there was you mentioned earlier that there are two ways to do it, which is using extra backup, Percona's extra backup service, or the extra backup, or use the snapshot feature at the center level. So I think maybe you can speak a little more about that, because that was the basic question: is what is the best way to back up?
Okay, so let's say we're talking about a full backup. With a full backup, what extra backup will do is a full copy of all the data. So if you have, let's say, 100 gig, you'll need to read from the disk 100 gig and write 100 gig somewhere. That will take time. It puts loads on the server, so it's slow down, and it's synchronous. Galera is a synchronous protocol, so if one of the nodes is slower, all the nodes are slower. So to process at least writes, they cannot, this node, since it's busier, the node that does the backup, if it's busier doing the backup in terms of IOPS, it will not be able to write as fast as the other one, and you'll have what we call in Galera, inside the Galera protocol, you have flow control that will slow down everybody. So it's the main way to do backup right now with extra backup. But if you have snapshots, I mean, that's like so much better that you cannot not want to do snapshots if you can. To do a snapshot is you just need to have a consistent state of the database at one point. So XRDB cluster needs to do the same at one point to get the slave position and all that. It's usually close to the end when it copies the ISM and FRM files. It does a full table which read lock on a flush table which read with write lock on the database server, just to have that consistent position. With a snapshot, you will still have to do the same, but you just need to tell the snapshotting infrastructure, okay, start here. And like with Ceph, to put the timer or the label where the snapshot starts, it's a copy and write setup. It's very easy. It's very short. So instead of holding that lock for some amount of time, it's a second or two. It's very short. So, and snapshots with Ceph can be mounted on any nodes part of the Ceph cluster, so it's very, very easy, or that has access to Ceph basically. So I really think if you can do snapshots, it's so great. I had not using Ceph, it's a regular setup, not part of the OpenStack. I once worked on a server that was running ZFS for Linux, and we were doing full backups every 5 minutes on a 1 terabyte database. It's a snapshot. It's free. So you do snapshots every 5 minutes, and you remove the snapshots from an hour before. So just to keep the number of snapshots not too large. But it's super cheap. So it was very interesting to do that.
Okay, thank you. I have another question here, which is this bench the best tool to do the load performance testing? And have you done any performance testing? Do you have any performance numbers to share for Ceph storage? And I think the answer is, maybe you can try to answer it, and if you can't, maybe I'll take the question too.
Yeah, I mean, I realized while writing the slides that I never did that. So I had not much time, so I jumped and used Sysbench. TPCC would be probably better to evaluate the performance at more realistic database load, but no, I don't think Sysbench is the best tool for do that. I did the file IO test, so that's very simple. I got the numbers I wanted. It's not threaded, so it worked. So.
Right. And as a follow-up to that, what I'd like to add is that one of the things that we are doing here at Percona is we, as you mentioned, we have an OpenStack lab, and so one of the things we are looking at is doing performance, what makes sense, and we are looking, we'll be doing that, and we'll be publishing and sharing the results, through a blog post or otherwise, and so stay tuned over the next few weeks and months. So that's the follow-up. Let's see if there are any other questions here. I think the other question really is, I'd like to understand the comment about no virtual IPs for MySQL HA. I guess maybe you can clarify that a little bit, Eve?
Is that within OpenStack, there's within a VM is given an IP. So it's a DHCP reservation. So far, it's perfect. There's no problem. So given the MAC address, you receive such an IP. But the compute nodes will set up rules, IP table rules that associate a given IP with a given MAC address. So if traffic, let's say you define a virtual IP, so you do IP, ADDR, add, blah, blah, blah. That IP doesn't have any match for the MAC address defined on the compute node. So in order for virtual IPs to work within OpenStack, some security feature needs to be disabled. I think it's possible with legacy network. I've seen a few examples, but with Neutron, I couldn't find them. The setting that is used with legacy doesn't seem to work at all with Neutron. I tried many times and never get it to work correctly. Those rules are always there. So again, I'm not a super expert in the OpenStack world. Maybe a guy that is very good with networking inside OpenStack, you do that and it works. But so far, I couldn't figure a way to get the VIP to work, so the way I want it. So because of those rules.
Yeah, I mean, I think the other thing that we can also do really is follow up with once we have that working, or if there are the alternatives, we can consider that and we can follow up. But thanks a lot. In quick summary for the audience, as you saw, you presented how to use MySQL in an OpenStack environment. As you saw, MySQL is used extensively, and as you know, Percona is a MySQL-based solution, and Percona has a Percona server and Percona XDB cluster, which is based on Galera, and Percona Extra Backup, which is the backup that he was talking about earlier. And so if we will continue to have a few more webinars on this matter, on the OpenStack related items over time, and stay tuned and check a recording. And I think Alyssa, my coworker here, will go over the details of the recording. But this session is being recorded, and you will get that. And hopefully, you can join us in future webinars. We'll be there at OpenStack in Paris, and so definitely stop by our booth there. Or we have a couple of presentations at OpenStack Paris. By a couple of by engineer and a consultant, and so there are more interesting webinars and blog posts coming from us. So stay tuned. With that, thank you. I'd like to thank Yves Trudeau for his talk today, and I'll hand it over to Alyssa for.
Hi. Thank you guys so much for a great show today. As Tushar said, we're going to, as you know, I run the webinar program, so I will be adding a few more for this year. A couple on OpenStack. I think we're having one November 12th, Tushar, is that the right date? PXC, Percona Extra DB Cluster, and OpenStack, and there'll be a couple of others this year as well. And then also we are planning an event for next year in conjunction with Percona Live that will be OpenStack Live. So that will be very exciting as well. So lots going on. Read our blog to get the most current updates, or subscribe to the newsletters, which I write, and I will keep you informed. With that said, everybody, thank you so much for your time today. If we didn't get to your question, I will make sure that that Yves gets a copy of everything, and he'll address everything in a follow-up blog post there. With that said, thank you so much for attending. I hope you have a wonderful morning, afternoon, evening, depending on where you're calling in from, and we'll see you on another show. With that said, thank you again. Everybody, take care.